we're going to look at lesson 20, which is going to be on transformations. So we're going to use this image for questions 1 through 8. You can see a bunch of transformations here. You can kind of see this cube, how it moves and it stretches, and that's what we're going to be focusing on for the next couple of days. So I want to make sure you understand these terms. A transformation is when you take a figure and you change its position, its size, or its shape. When we do this, we're going to call the pre-image the thing before the transformation, and the image is after the transformation. So instead of calling it like this being our image, and then these are this like new image or post image, if you're talking about transformation 1, you have the pre-image A turns into the image B. If you're talking about transformation 2, the pre-image B turns into the image C. So image will be after, pre-image is before. So use your own words and describe transformation 1. So just describe transformation 1, what's happening to this cube, what does it look like is happening in transformation 1. And then I want you to, what's different in transformation 1 and 2. So what's different when the cube goes from here to here, and what's different from here to here. So hopefully what you've seen is here, it's just sliding down, and that's how we get to this image. And then on this one, it's not sliding up, it's not sliding down, it's actually staying where it is, and then it's getting stretched. So the top moves up while the bottom moves down. The middle is staying right where it's at when you go from B to C. All right, so transformation 1 is an example of rigid motion where the object moves, but it keeps its size and it keeps its shape. So look at transformation 1. If you were to count, it's 1, 2, 3, 4, 5, 6, 7, 8. This thing is 8 units long, and even when it moves down, it's still 8 units long. And across, it looks like it's 1, 2, 3, 4, 5 units across, and over here it's 5 units across. So when it moved, it slid down, but the size stayed the same. So now I want you to do this. Figure A is mapped to figure B. We're looking at transformation 1. The corner 110 is mapped into which corner? Okay, so I want you to try to do 3, 4, 5, and 6. Try to figure out where each of these corners end up when you go from A to B. And after you try them, then come back. Press pause, try to do these, and then press play. Okay, so look right here. We're looking at the corner 110, which right here is 1, and then you go all the way up to 10. So what we're looking at is this upper left corner. How did this, where is its new location when we go over here? And the new location is at 1, 1, 2, 3, 4. You see that? For A over to B, the corner up here goes right there. So 110 turns into 1, 4. Where does 1, 2 end up? So let's go back to our original image. Here's 1, 2, the bottom left corner. Now it's at 1, negative 4. So it's at 1, negative 4. 6, 10, where does 6, 10 end up? Here we have 6, 10, so the upper right is right here at 6, 4. So 6, 10 goes to 6, 4. And then where does 6, 2 end up? So 6, 2 is going to be right here, the bottom right corner, and it's over here at 6, negative 4. So it's over here at 6, negative 4. So what we're going to start doing is writing as expressions. When we do that, you're going to have an arrow, and the arrow basically means it goes to. So what you're saying is you could say, so you could write like 6, 2, arrow means goes to, what did we say, 6, negative 4. So right here, so look, you can say 110 goes to 1, 4. That shows that the point 110, let's go back up to this. Sorry for getting dizzy, me moving up and down so much. But look, the point 110 goes down here to 1, 4. That's where it goes when we do the transformation. So let's do that, but for the whole function. So when you use this notation to show how our general point x, y is transformed, you're expressing the transformation as a function. Express transformation 1 as a function. So now what I want you to think, what happens? So does x change at all? Look right here, x is 1, and right here, x is 1. So did x change at all? No. Wherever x is, that's where x stays. So it always starts out as xy. We're going to pick one of the ones where x doesn't change at all. So right here, x is going to go, it's going to get 6 smaller. Right here, it's going to go down by 2. Right here, it's going to go up by 6. This one, x stays the same. So far, the second option looks pretty good. And look at what y does. Y goes from 10 down to 4. How much is it going down? It's going down by 6. And look right here. We're talking about y, and whatever our y is, we subtract 6. So this right here is our correct answer for number 7. So what this is saying is x stays the same and y always goes down 6. Let's look at the figure. What happened to this figure? Look at it. Did x stay the same? Does it scoot left or right at all? No, it certainly doesn't. But look at what it does. All the points slide down 6 places. Look at this point. Slide down 6 places, you end up right here at 1, negative 4. 1, negative 4. Look at this point. Slide down 6 places, you end up right here at 4, right? 6, 4. You see that? So all of our points just slided down 6 places. And now let's express transformation 2 as a function. Transformation 2 is kind of interesting. Let's look at what happens here. So look right here. Our upper left corner is at 1, 4. And now it goes from 1, 4 up to 1, 8. So did it go up 4? Well, it looks like it. Look at this corner. We're at 6, 4. We go up to 6, 8. Right here, we're at 6, 4 up to 6, 8. So on the top, it goes up from 4 up to 8. However, is the bottom sliding up 4? Look at the bottom. Did the bottom go, where was it at? It was at negative 4. And did it slide all the way up to 0? No, it didn't. Instead, it went from negative 4. It went down to negative 8. So look what happened. 4 turns into 4. 4 turns into 8. And negative 4 turns into negative 8. What's happening to y? X is staying the same, but what's happening to y? What can you do to 4 to turn it into 8? You could either add 4 or multiply by 2. What can you do to negative 4 to turn it into 8? Negative 8. You could either subtract 4 or multiply by 2. So what's the thing that's happening to both of these? Multiplying by 2. So x stays the same, y is multiplied by 2. So let's look at the option that gives us that. We go from xy, x adding 2, nope. X doubled, nope. X stays the same, add 2 to y, no, not quite. Here we go. X stays the same and y gets doubled. Okay, what you're going to do, you're going to do 6 more of those. Well, you're going to look at 3 more figures. You're going to say if they're rigid for 3 of your next questions. And for the other 3 questions, you're going to decide what kind of motion happens. So what I want you to do, I want you to press pause. I want you to try to do the rest of this assignment, and then you can press play and I'll go over it. Okay, let's look at this. Is this thing rigid? Does this box stay the same shape when it moves over here? Yeah, it's a 3x3 little box. So it's rigid. Now let's just look at what happens. Instead of thinking through, like trying all of these, let's look and decide what's happening for ourselves. So look at where we're at in terms of y. Y right here is at, so it's at 2, 2. And we slide all the way over here to 1, 2, 3, 4, 5, 2. You see that? You go from 2, 2 over to 5, 2. So does your y go up or down at all? No, it doesn't. What happens to your x? Your x goes up by 3. Let's see if that works for this point right here. We're at 1, 2, 3, 4, 5. So this bottom right corner is 2, 5. Where's bottom right over here? 1, 2, 3, 4, 5, 6, 7, 8. So we go from 2, 5 to 2, 8. Once again, we went up by 3. So what's happening here, y stays the same, x goes up by 3. So x plus 3, yep, and then y to y. So here, y stays the same, x goes up by 3. There's our answer. 11 through 12. Is this rigid or is it non-rigid? Well, it looks like it's gotten bigger, so it's definitely non-rigid. Okay, now let's figure out what's happening to this. First off, our x was right here at 1, and now our x is at 2. And then this x, bottom right, was at 1, 2, 3. This x was at 3, and now it's at 1, 2, 3, 4, 5, 6. Okay, I'm just looking at the x value of the bottom corners. Right here, we're at 1, 2. And right here, we're at 2, 1, 2, 3, 4. So let me actually do this. Let's do this. This might help for you to see what I'm doing. So look at this. Bottom left was at 1, 2. So we went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, if this thing will let me write. We went from 1, comma 2, and we turned it into 2, comma 4. All right. So that's the bottom left corner. Let's look at the bottom right corner. It's at 1, 2, 3, comma 2. So bottom left corner is at 3, comma 2. And it gets turned into, let's see, bottom right corner over here. 1, 2, 3, 4, 5, 6, comma 1, 2, 3, 4. So 6, comma 4. Can anybody tell what's happening already? What's happening to x? 1 turns into 2. 3 turns into 6. X is getting doubled. What's happening to y? Well, 2 to 4 and 2 to 4, it's either adding 2 or it's getting doubled. It's hard to say. So let's look at the upper left corner. X is 1. Y is 1, 2, 3, 4, 5. So 1, comma 5. And then let's look at the upper left right here. So it's x is 2, comma 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we go to 2, comma 10. There we go. Look at that. 1 turns into 2. X is being doubled again. 5 turns into 10. We're clearly not taking y and going up by 2. We're going up by 5 this time. So actually we're doubling y. So it's doubling x and doubling y. So let's look at our options right here. Which one are we doubling x and doubling y? This right here. All right, last one. This thing looks like it's just scooting straight down. It's 8 long, and right here it's 8 long. Across, it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Does it stay the same shape? Yes, it's rigid. It doesn't change the shape. But let's see how it moves. Is it going left or right at all? Look at our corners on the left. Our upper left, our bottom left are both at x equals 1. And here, x equals 1, you have your upper left, bottom left. Over here, x equals 6, bottom right, upper right. Over here, x equals 6, bottom right, upper right. So x doesn't change at all. So out of our answers, we're using one of the ones where, so we already know this is going to be the right answer because x doesn't change. But let's see what y does. Y upper left is at 10. Now it's at -2. How can you go from 10 all the way down to -2? That's going down 12. Minus 12. Look at this. 2 all the way down to -10. 2 minus 12 will give you 10. Same with this side. So we're totally happy with this answer. X comma y turns into x comma y minus 12. Hopefully this makes sense. This is the kind of thing that I think if you're comfortable graphing from Algebra 1 and 2, this will be a lot easier. If you struggle with graphing, this might take a bit. But as always, do your best and email me if you have any questions.